Welcome back, Algebra 2. This is day 2 from our at-home learning. I'm going to start doing a Pop Funko of the day. So today's Pop Funko is Thanos in his ship. Given that yesterday was, I think, the 1-year anniversary of Avengers Endgame, I figured this would be a good Pop Funko for the day. So there we go. We'll do that every lesson. Linus, really? Already? You can give a minute. What are you doing? We just started. All right, I guess we have a new student. Today we are going to learn about conditional probability. I'm going to go through 4 examples. 2 of them are going to be examples like these where we have tables involved, and the other 2 examples are going to have a tree diagram involved. All right, so for this one, I've already got the table drawn and the 4 questions that'll follow. Hopefully you guys can see it. I'm going to zoom in here. I'm going to stay seated today. It's kind of hard to write on this board. All right, let's take a look. Okay. All right, so this table represents people that are applying for a job. And let's take a look at it. These categories, these are people that have experience already. So yes, they have experience, or no, they don't. This side is people that have a high school diploma. So yes, they have a high school diploma. No, they don't have a high school diploma. All right, so let's look at example number 1. It says the probability that someone has a diploma, okay? So I look at my table, has a high school diploma is this row right here. So I'm gonna add those 2 numbers together. 54 and 27, I believe that gives us 81. And then out of what though? It's gotta be out of the total amount of people. So if we have 81 and we add 9 to it, that gives us 90. So the probability that somebody has a diploma would be 81 divided by 90, which gives us 0.9 or 90%. All right, has a diploma would be this row right here. Add them together, that gives us 81 out of 90 total. Let's look at number 2. The probability that someone has a diploma and experience, okay? So when I look at this, I want to say, okay, well, here's the people that have a diploma, but now out of those people, how many of them have experience? Not this side, it's got to be this side. So 54. So that would be 54 out of 90 people total, which I believe gives us, look at my notes, about 60%. All right, for those of you that are at home trying this on your calculator, you would do 54 divided by 90. It would give you a decimal. Move the decimal 2 places to the right, and that would give you your percent. All right, so example number 3, this is the probability that someone has experience, and then this little line right here means given. Okay, and what that does is that's going to change our total amount of people. So this reads the probability that someone has experience given that they have a diploma. All right, so our total is no longer out of 90. Our total is going to be the amount of people that have a diploma, this side of the line. All right, so look at your table. How many people have a diploma? Has high school diploma would be this row right here. So 54 and 27, that gives us 81. So that's our new total for this problem. So out of the people that have a diploma, how many of them have experience? So here's our diploma people. Of those, 54 of them have experience. So for this one, you would have 54 out of 81, which is about 67%. Also, when you guys are doing the percents, if you round up or down, depending, I don't care, whatever you choose. As long as it's close to this, I'm fine with it. So one question that you guys might have, and my wife had the same question, was why is it not 59 out of 81? So I add the people that have experience, which would be 54 here and 5 here. Why would it not be 59 out of 81? And that's because these 5 don't also have a diploma. They have experience, but they're in the bottom part. They're in the no category for having a diploma. All this wants is out of the people that have a diploma, so that's just this top row here, because those are all the ones that have a diploma. Of those people, how many of them have experience? Well, it would just be these 54 right here. Okay, so hopefully that kind of maybe clears up some confusion there. Again, if you ever lost, pause the video, go back, rewatch it. It'll be helpful. Last problem is the probability of someone who has no diploma given that they have experience. Okay, so our new total is going to be the people that have experience. So has experience, that would be this column right here. So 54 and 5. So our new total is going to be out of 59. Those are all the people that have experience. I don't care about this part yet. I'm just looking for the people that have experience. That's the bottom. Now, of those people, how many of them have no diploma? Okay, so of these people, 54 have a diploma and 5 have no diploma. So that would be about 8%. Okay, there's our first table. So for our next example, we have the degrees. Just think of like a college student. You have the degrees you can get, an associate's, a bachelor's, or an advanced, like a master's degree. And we have the number of males and females that receive those degrees. Okay, so these are the males that received associates. Hopefully you guys can kind of read that. These are the females. We're gonna have 4 quick questions. I'm gonna do these 2, erase them, and do the next 2. First one is the probability the person is a male. Okay, so here is all of my males, this whole side. I gotta add all those up. When I add those up, I get 1,016. Those are all my males. Out of all the people total, that would be 2,501. I did the math beforehand. So the probability the person's male, if I divide those, I get roughly 41%. All right, easy enough. The second one, the degree is a bachelor's. Okay, so I need all of the bachelor's degrees. All the bachelor's degrees would be these 2 numbers added together, which gives us 1,323 out of all of the people total, 2,501. This equals about 53% when you divide them. All right, now I'm going to erase these 2 and put the next 2 in. All right, for our last 2 examples here, these ones have to do with given conditions. All right, so remember our totals might be a little different. For the first one, it says the person is a female given that the degree is advanced. So my total is going to be the second part here, all of the advanced degrees. So advanced degrees would be these 2 numbers. When I add those together, I get 567. So that's my total of the advanced degrees. Now, out of those, which ones are the females? So it'd be this side right here. So 322 divided by 567 gives us about 57%. And our last one, the degree is not an associate's, given that the person is a male. Okay, so our total is going to be the males, which is this side. I think from earlier we added that up. That would be out of 1,016. Still see that? So out of all of the males, we go back to the first part of the problem, the degree is not an associate's. So these 2, so this one is associates. That means we need to add these 2 together because of all the males, these numbers are the ones that are not associate's degrees. So when we add those together, we get 792 divided by 1,016 gives us about 78%. All right, now these ones did look a little different from the first table. In the first table, you saw a line that separated the 2 parts if it was a given condition. Here, it just says the word given. Okay, so whether it says the word given or if it has a line going up and down separating them 2, just know that your total is going to be whatever this second side is. All right, for our last 2 examples, we're going to look at what's called a tree diagram to help us solve these problems. There's going to be some multiplying involved as well. I'm going to actually read off the sheet here. That's my note sheet. The question says, make a tree diagram based on the survey results below. Then find the probability of a female respondent that is left-handed, and find the probability that a respondent is male and right-handed. And this is the information, this is all the information they give us. It says that 17% are male, of the males, 33% are left-handed, and of the females, 90% are right-handed. Okay? So when we make a tree diagram, kind of looks like this. Okay, now we need some categories. Based on our information, we know that of this survey, you can either be a male or a female. How many are males? Well, it says 17% are males, so 17%. Now, it doesn't tell us what percent are females, but we know that these need to add up to 100%. So if 17% are males, I would just subtract that from 100. That means that 83% are females. Okay, when we do this, every little tree, we call it branches, every little pair of branches needs to add up to 100%. So now let's keep branching off from here. Of the males, 33% are left-handed. So I'm just going to put LH for left-handed. That would be 33%. Okay, well, if you want to complete this branch here, 33% are left-handed. What percent would be right-handed then? Needs to add up to 100, so this has got to be 67%. Okay, so of the males, 33% are left-handed, 67% are right-handed. Now, it didn't tell us that, but we have to figure that out on our own. Same thing for the females. Let's go down here. Of the females, look back at our data here. Of the females, 90% are right-handed. So keep right-handed on the bottom. So 90% have to be right-handed. That means that there would be 10% left-handed. Just to make sure your tree diagram makes sense, make sure all your branches or all your pairs of branches add up to 100. That makes 100, those two make 100, and those two make 100. So I know I did this correctly. All right, now let's look at how we solve our problems here. So let's take a look at our first problem here. It says the probability of a female respondent, the probability that a female respondent is left-handed. Okay, so basically what I want to do is I want to take your pencil, finger, whatever, and just trace a path. Make sure it goes over a female that is left-handed. So it would be female, left-handed. So these two spots, female, left-handed. That's 83% times 10%. So that would be 0.83 times 0.10. All right. 83% as a decimal, we'll just move it back twice, it'd be 0.83. 10% as a decimal, move it back twice, it'd be 0.10. All right, when we get this, we multiply those together, and that gives us, look at my notes here, about 0.083. We usually want to write it as a percent. Right now it's a decimal, so we would move the decimal twice this way. That would be 8.3%. Okay, so again, just trace with your pencil. I want a female that is left-handed. So those two numbers are what I'm multiplying together. Okay, next one, a respondent is male and right-handed. Okay, so male, which is 0.17, times male right-handed, 0.67. Male, right-handed. When we multiply those, we get 0.1139 as a decimal. I want it as a percent, so I move it twice. That would be 11.39%. Okay, remember if you're rounding, as long as it's close to this, I'm cool with it. All right, our last one here. I'm not going to write any of the stuff down beforehand. I'm just going to read it and kind of write as I go. So make sure you're paying attention closely. It says a football team has a 70% chance of winning when it doesn't snow, but only a 40% chance of winning when it snows. Suppose there is a 50% chance of snow. Make a tree diagram to find the probability that the team will win. Okay, so we're going to take what we just learned in our last two examples, we're going to kind of build on it. Somebody on a motorcycle thinks they're tough. All right, so let's start our tree diagram. It says there's a 50% chance of snow in the weather. Okay, so we'll put snow and no snow. Okay? So boom, boom, boom. It says a football team has a 70% chance of winning when it doesn't snow. So no snow, we'll say win. They've got a 70% chance. Okay, don't forget 50% snow, 50% no snow. Because remember the problem said there is a 50% chance of snow. So if there's a 50% chance of snow, it didn't tell us there wasn't a 50% chance of no snow, but you have to make sure it adds up to 100. Back to this. So when it doesn't snow, if this team has a 70% chance to win, that means they have a 30% chance to lose. It also says they have a 70% chance of winning when it doesn't snow, but only a 40% chance of winning when it snows. So go up to where when it snows, there's only a 40% chance that they win when it snows. That means, again, it's got to add up to 100, so that means that this, for a loss, has to be 60%. All right, now each category adds up to 100. 100, 100, 100. Our tree diagram is correct. Now let's look at what the question says. Find the probability that the team will win. So the probability the team will win. Okay, and this one's a little different because there are two scenarios where the team wins. They can win when it doesn't snow, and they can win when it does snow. So here's what we have to do. Let's start with the top. Let's find out the probability of them winning when it snows. That would be 0.5 times 0.4. 0.50 times 0.40. And that equals, depending on how we round, that equals 0.2 or 20%. So that's the probability of them winning when it snows. Now let's find the probability of them winning when it doesn't snow. That would be 0.5 again, times 0.7 this time. And that equals 0.35 or 35%. Now, the question says, what's the probability when the team will win? It doesn't say when they win if it snows or when they win if it doesn't snow. It just wants the probability of when they win. So we need to take these two percentages, the probability of them winning when it snows and them winning when it doesn't snow, and add them together. So 20% plus 35% gives us 55%. So no matter what the weather is, they have a 55% chance of winning. And that is all we have for tree diagrams.